Hi, everybody. Welcome. This morning, I'm going to give it just a minute for a few folks to filter in as we get started. For those of you who don't know me, I'm Hannah Neuschwander. I am our Director of Communication and Strategy at World Coffee Research. Today, we have a really exciting WCR Presents webinar on rethinking coffee carbon accounting. This is part of a series of webinars where we bring in outside experts who are experts in their field and related, doing work, research and work that is integral to understanding coffee agriculture and how we improve the sustainability of coffee agriculture, productivity, etc. And today we are going to be talking about a topic that I know is on many, 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 many people's minds, coffee carbon footprints, coffee carbon accounting. We have produced a new white paper written by the two gentlemen that you see here in front of you and with whom we're going to be talking today on rethinking coffee carbon accounting that looks at some of the tools that are available and improvements to the approach to coffee carbon accounting that might be needed to really be producing accurate estimates of coffee's carbon footprint, especially at the farm level. So we're going to walk through the white paper, some of the main findings of the white paper, and then we're going to have a conversation. And we are so delighted and honored to have with us today two real experts in this area. Before I introduce them, I just want to thank our 200 plus member companies who make this work possible. Without their support, we would not be able to conduct our research agenda and be able to bring topics and events like this forward. And in particular, we really want to thank our global sponsor, Folgers. Okay, so without further ado, we are joined today by two wonderful scholars from the Rattan Lal Carbon Management and Sequestration Center at The Ohio State University. We have Dr. Umesh Acharya, who's a postdoctoral scholar at the center and who's the lead author of the white paper and who will be describing the white paper for you. And we also have Dr. Rattan Lal, who's the director of the center, and his accolades and accomplishments are really too many to be named individually, but he is a preeminent scholar on soil science. He's the winner of the World Food Prize, and he is going to offer some commentary and context for us to think about why this all matters and what the opportunities are for moving things forward in coffee, bringing his expertise to coffee. So with that, I'm going to turn it over to Dr. Lal to kind of kick us off, and then it'll go to Dr. Acharya, and then we will have ample opportunity for discussion and questions. So please feel free to start entering your questions now in the Q&A chat, and we will bring them forward at the end of the session to get us started. So over to you, Dr. Lal.
Thank you, Hannah. Thank you for that introduction. And I also join you in welcoming all those who are attending the webinar today. I also want to thank the WCR, especially Dr. Long, the CEO, Hannah, Alexa, and many other colleagues who have been organizing this. And it has been a pleasure working with you all on this project. I want to make very few kind of light comments, not technical detail. To a scientist, every thematic topic ends in the term ology. Naturally, the discussion topic today is coffeeology. I hope you agree with this new science that we are coming up with. I had a classmate, his name was Rudy Aliman, and Rudy was here at Ohio State. I'm talking about 60, 65 years ago. He was in soil science, but was from Central America, was very used to coffee. And when he found out that I didn't drink coffee, he couldn't believe that I was real. He said, the real people all drink coffee. And he's not sure whether to trust somebody like me who doesn't drink coffee. And anytime something went wrong, he would also say, gee whiz, this coffee tastes like dirt. And to a soil scientist, you understand what that may means. Dirt is, of course, a soil and not a living entity. And I always talk to my students, we should never treat soil like dirt. And to every soil scientist, that's an important concept, that soil is a living thing. It breathes. And because it breathes gases, just like human breathe, we want to quantify those gases. And therefore, when we talk about carbon footprint, Umesh is going to talk very briefly what that breathing is involved. So Dr. Umesh Acharya started with us as a postdoc about 2 months ago. And the first assignment that I suggested to him was to find out how to do the carbon footprint of a coffee from seeding to harvesting. What are the factors involved? And essentially, our goal is to make coffee plantation pro-nature, nature positive agriculture practices, and to make it as a sink of atmospheric CO2 through sustainable management. And that is the topic that Umesh, could you please describe? After he's finished, I will give you some summary comment and then we'll continue discussion. Umesh, floor is yours.
Thank you, Dr. Lal. Now, today we are going to talk about the carbon and in the coffee farming system. That's why WCR has provided us the opportunity to work on this research. And I also want to thank WCR and Dr. Rattan Lal to provide me this great opportunity to work on the carbon footprint of the coffee. And I just want to jump on, and this is the front page of our paper, that is the carbon accounting for coffee-based farming system. And the objective of this paper the objective of this paper is to synthesize the information on the commonly used tools to estimate the carbon accounting in the farming system. We have different types of tools which has been used in the agriculture and some has been used in the coffee. We just want to synthesize what's going on with those tools and how those tools are using uh, used in the coffee farming system. And we discussed the pros and cons of those tools while using it in the coffee farming system. And in addition, we have reviewed the recent research on the coffee carbon footprint. And finally, with the synthesis and with the understanding of the tools, its pros and cons, we propose the improvements to measure the coffee's carbon footprint. And when we talk about carbon footprint, they are basically calculated with some of the international standards, and based on those standards, tools are developed. Now, there are so many standards that has been developed and has been used in the farming system, and those are basically developed by the institute or by some of the specific countries, and some of them are listed here. For example, French Agency for the Environmental and the Energy Management, and the most popular is IPCC 2006, which is Intergovernmental Panel on the Climate Change. They have developed a standard. And the Department of the Environment, Food and the Rural Affairs, that is of UK. And another one which has been used is publicly available standards, that is PAS 2050, and the British Standard Institute, and the project carbon footprint of the products from the Germany. And finally, in 2018, the ISO standard has been developed for some of the standards that can be used in a tool to estimate the carbon footprint of the different agriculture products. And let's see what are the common tools which has been used in the carbon footprint. It is the first one is the smallholder agriculture monitoring and the baseline assessment, that is developed by the University of Edinburgh. And some of the other are agriculture resource efficiency calculator and farm carbon calculator, cool farm tools, ex-ante carbon balance tool, and CBP modeling, measurement, and the monitoring. Look here, these tools has been developed by the different agencies and different universities based on the project or the funding they got for the specific objective. Here, some have the objective of just comparing the two different projects to see the efficiency of the carbon use or the carbon footprint, and some has been based on the and comparing how you can save the carbon by the afforestation. And similarly, the cool farm tools has been most commonly used in the recent years, so that you can measure the carbon footprint of the product. That has been used in most of the research in the coffee too. And we have in this white paper we have compared, or we have analyzed all those tools and shows the pros and cons, advantages, disadvantages, and the significance of these tools. And the final one is the agriculture and land use national greenhouse gas inventory software. Then, with all this understanding, what do we know about the coffee carbon footprint? With all this research in past 20 years, what do we know? The first thing we found was there was the large variation in the coffee carbon footprint estimation, that is 0.4 kg to 10.8 kg of the carbon dioxide equivalent per kg. And that per kg, and why that variation is there? The variation is not only due to the different types of the tools used, or the different location that has been studied under. Because those researches has used different types of tools and following the different standards, that's why that variation has been there. And those the carbon footprint has been done basically to compare the different farming system, that is polyculture versus monoculture, shade versus sun grown, and the conventional versus organic. They just compare those different farming system. And while comparing those farming system also, they have only considered few aspects, or the few inputs, or the few tools. Here we can see most of the research has studies the fertilizer and the pesticide rate and the application, and the fuels used in the farm operation. And they move to the milling, that is wet and the dry milling. That is, now most of the research has been towards the processing of the coffee rather than the production of the coffee. And the transportation, roasting, and the grinding, most of the research are based on the second part, but our main focus is the first part. And the first part, whatever the research we have seen it is they have used the fertilizer and pesticide rate and fuels used in the farm operation. Very few research has some of the inputs that is related to soil carbon and the carbon sequestration. And why we are talking, there is the specific need for the coffee, and why we are talking about the carbon footprint of the coffee cannot be used similar to the other different annual crops. The first one is it is the perennial crops, and it takes about 3 years to start the fruiting, and and the life cycle continues all the way to 30 years. And within that we have different cultural, intercultural activities and the farm operation in between that one. That's why this is the special condition here. Whatever the tools we are using to develop, that should consider the perennial nature of the crop. And another is the diverse cropping system. You can see in the coffee, it is shade grown or sun grown. And if it is shade grown, there might be the fruit trees or the leguminous trees or the other shade trees. And if you follow the organic or conventional, the different diverse farming cropping systems are there. And in the diverse cropping system, we should have to measure what type of the carbon dynamics is going on, how carbon is input and how carbon is lost from that system. And the third one is the agriculture management system and the soil carbon stock in the soil carbon stock. And the fourth one is, I have already mentioned, it is the shade system. If we follow the agroforestry, it's the fruit trees, it's the legume trees, what will be the dynamics of the carbon in there? And what will be the greenhouse gas emission? And another is the slope, because I haven't seen any research that consider the slope and the loss of the soil carbon during the soil erosion, because coffee is grown in the steep slope and the tropical climate and a lot of rainfall, around 1400, more than 1400 millimeters of the rainfall. And under that scenario, there is a chances of the erosion, and that erosion caused the movement of the soil carbon from one place to another. I think that is one of the another aspect missing in this carbon accounting. That's why finally, after our research and understanding of the tools, what we found, some of the critical things missing in carbon footprint of the coffee are above and below ground biomass, that is the shade trees and the coffee plant itself. And the second is soil carbon stock in the farming system, because there is a change in the carbon stock every year. And I just want to mention soil is a huge source of the carbon. It is around 2,500 gigaton of the carbon is in the soil, which is 3 times more than in the atmosphere and 4 times more than the living system and the agriculture. That's why it is a huge, that's why we have to take into consideration about the soil. Once the coffee is planted, we are done for 25 years. That's why a thorough research is needed to see what happens in that kind of a coffee farming system. And the third one is the greenhouse gas emission from the soil. It is a huge thing. The greenhouse gases, either it is CO2, N2O, or methane. And under these kind of rainfall or the agroforestry system or the shade system, the dynamics of the greenhouse gas emission is different. And we have to take greenhouse gases emission in consideration to calculate the carbon footprint of a coffee. And the final one is the soil carbon loss due to the erosion. As I have already mentioned, we have to take that thing into the consideration because of the climate and the rainfall and the type of the slope we are growing coffee in. Taking all those things into the consideration, what we have proposed is the new carbon accounting system. Here, basically, we went with the basic mathematics. The first one is how much carbon is input in the system and how much carbon is taken out from the system. If we subtract it, we can get the net carbon balance. And if we divide it by per year production of the green coffee, then we can find out how much carbon it utilized to produce per kg of the green coffee. And here one important thing is we try to suggest the tools to use yearly carbon balance so that we can see, because as the age of the coffee grows on, there is a high production and slightly low production some year. That's why we have to consider all those balance. We cannot just go and take a consideration for the 20 years. We have to go yearly, and if we need for the life cycle, then we can edit all and find out how much carbon balance was there from 0 years all the way to 20 years or the 30 years. And in that one, the formula is simple. What is the carbon balance per year? And if it is the negative, it is the carbon lost. And if the value is positive, then we can say the carbon is sequestered. And the first one is the addition, the input will be from the above and the below ground biomass. If it is of a shade system, if it is a sun grown, if it is the agroforestry, if it is with the different fruit crops, then we have to calculate how much changes there is in the above and the below ground biomass. And the second is the soil carbon stock. How much changes is there in the soil carbon stock in every year? We have to calculate that one. And the third one is the loss of the carbon due to the soil erosion. We have to monitor that every year, because in alternate year or in every 5 years, you might have a huge amount of the rainfall and the topsoil might be washed away. And for that case, we have to have a measurement system for that loss too. And finally, the another most important, which I have seen missing everywhere, is the greenhouse gas emission from that system, and which can be computed in the CO2 equivalent. And finally, we have to include those farm inputs from the fertilizer, pesticides, and the energy that has been used, like as the petrol, electricity, whatever has been used during all those farm operations, that should be converted into the carbon equivalent and put it in the use of the carbon. And the GC is the green coffee yield on that particular year. Now the question might come, what about for the entire farming system or the entire crop life period? We can add every year. And another thing is we have to see the dynamics, how that carbon balance happens during the different year of a production too, so that we can make the decision or we can improve in our farming system likewise. Finally, the overview or the main findings of the white paper. There are very limited studies on the carbon footprint of the coffee. I have seen one study that has been done for the 7 years. Other most of the studies there has been like 2 3 years or 4 years or very short duration, and they try to use the previous data of, by talking with the farmers or some of the data, and that data might not give you the clear information. That's why we see the large variation in the carbon footprint of the coffee. And whatever we have presented some of the examples in the white paper and try to calculate the net carbon emission by using our proposed method. You can see that one in the paper also. And the third one is CFE ranges vary widely due to the use of the different methodology and the tools. I think that things for that one also we should have one streamlined tools and the standard that can be followed, compared, and like the like and then can be used as a reference for all the farming system. And some of the key component missing in the CFA calculation were greenhouse gas emission, soil carbon stock, and soil carbon loss due to the origin and the change in the biomass. And finally, the proposed new accounting system includes the missing components to produce the accurate emission figures that will help the carbon-friendly management practice of the coffee growing system. And I want to thank you here, and I want to request Dr. Rattan Lal to give the concluded remarks for this presentation.
Thank you, Umesh. Thank you for a very comprehensive presentation. I think rather than taking more time, what emphasis is that there is a need for standardization of methodology, considering all components of production system. And that is really the future goal. How do we standardize the methodology, and how can we provide the data on carbon footprint over a very short period of time? With that, Hannah, Warren, back to you for any discussion and questions. Okay.
Hi, Dr. Lowell.
Thank you.
Wonderful to have you. Vern, I'm just checking real quick to see if you're able to connect. It seems that we can't hear Vern. Okay, so I'll go ahead and get us started on questions. Vern may dial in another way here in just a minute. I will go ahead and turn her off. So my first question is for Dr. Acharya. You can go ahead and bring yourself back into the conversation, turn your mic and your camera on.
Okay.
As you reviewed the literature for this project, what, and given your experience and your knowledge of how carbon accounting is done in other crops outside of coffee and maybe even outside of tropical agriculture, what surprised you about what has been done or what has not been done in coffee agriculture related to carbon accounting? What do you see as the biggest gaps in information, the studies that you expected to find, maybe that other crops have that coffee doesn't, or approaches that were new to you based on your work in other crops?
Thank you, Hannah. Yeah, whenever I started looking at the literature review and the work on the carbon footprint of a coffee farming system, I think the first one, what as a soil scientist, what I feel is we hadn't jumped into the soil at all. As I have already mentioned, we have like as a 2,500 gigatons of the carbon, which is in the soil. And from the production and from the sale point of the coffee, I have seen huge increase in the past decade in the production as well as in the consumption of the coffee. But I haven't seen I haven't seen, and for that only, there is an increase in the area. There is a cut down of the trees or the change in the farming system. People has been seen coffee as a productive and very benefited crops. That's why people are increasing the production and the production producing area. But what I haven't feel the missing point is the soil. They haven't considered the soil. And
Mhm.
another missing point is I have seen all the carbon accounting of a coffee literature review, and I found that most of the research has been focused after the green coffee is harvested,
Mm.
and after that we can see if it is for the milling and sort of the transportation and the grinding and all the way. We even talk about the carbon footprint of a latte with compared to the black coffee,
Mhm.
you know but my main emphasis and my experience on working on the soil is, so there is a fixed soil. Population is increasing and the demand of the coffee will increase in future. That's
Mhm.
why we have to make it, because the soil is not going to increase.
Mhm.
That's the thing. That's why we have to save the soil or the health of the soil, and the health of the soil is directly related to the carbon, to make
Mhm.
it healthy. I think that is the perspective of looking as a carbon. I think there should be some of the prospect from the soil science perspective or protecting the soil. You have seen the worst and worst example of like overuse of a soil, from
Mhm.
the dust bowl in the 1930s
Mhm.
for the 10 years. Like we don't want to happen next one, because in the next in around the world also you can see so many examples of the soil erosion, and because we haven't considered the soil health. That's why my main point is we haven't ha- we I couldn't see so many like a carbon sequestration in the crops or the emission from the soil. And at least there is something on the soil. I have been seeing like there is a carbon in the soil, and I haven't seen any study related to that, particularly
Mhm.
in the coffee. I
Mhm.
think we have to go back from the start, and my starting point is soil. Yeah.
That's wonderful. Thank you. Do you have any specific recommendations for what information, what research is needed in order to improve carbon accounting, maybe particularly around soil carbon? What would need to be done in order for us as a sector, as an industry, in order to be able to more appropriately account for soil carbon?
Um, I think from my perspective, there are the different research with the different objectives. And if you write some proposal and get money, like from some university, they try to develop their own kind of tools. I think that's the kind of dispersed work on the same field. Like there is an organization, World Coffee Research. I think they can be in the center point and try to get like the interested, if there is a universities and if there is the different companies, and they can divide a sector based on the common climatic areas,
Mhm.
and you can study working on the carbon footprint of the coffee farming system, and it won't be late anyone anytime. And if you just started, that you can start where the coffee is already grown, and if it is at the early stage, then by that one you will have some kind of data, you know and data will give you some kind of idea what's going on in the
Mhm.
past 5 years or past 10 years. You could have a coffee of the 10 years, the coffee farm with the 10 years of the coffee, then take the soil sample and study that for 2 years. And similarly you can study for the first and the second year of the different farm of the
Mhm.
same area.
Mhm.
And in that one we can get in the short time also, we can evaluate under the similar kind of a system what kind of a uh, what kind of a carbon dynamics is going on in there. I think by
Mhm.
that one, because it is a perennial of 30 years, do anybody want to start a research for 30 years and give a result? No. But you can do it in the split wise and
Mhm.
targeting for if it is for like at Africa, you can have a one sector, and in for the South America, and you have one, and in for the Indonesia or Colombia or in the Indian area, you can have a one, and you can just combine the resources and see what's going
Yeah.
on the part of the soil. Because I'm a soil scientist, I just see everything through the soil, and that's where the carbon is. And that's why we are talking all about and everywhere. I think, and from that steps, we can just give the farmers or the coffee growing farmers the credit for sequestration carbon or the carbon, and then they will get motivated. You know, I
Yeah.
think that is the motivation for the farmers and motivation for the crop drinker, and again for the companies. These are all the plus point. That's why I think we have to start research from the field itself, in the split wise, selecting the region area under the big platform, like what we are talking about as the World Coffee Research.
Thank you, Dr. Acharya. I'm going to see if it's possible to bring Dr. Vern Long, our CEO, back in to continue the conversation. Vern, are you there?
Hello. Yes.
Okay.
Welcome, everyone. Thank you. So I'd really like to build on Dr. Acharya's comments and bring in Dr. Lal to this conversation. When we think about science guiding good decisions and guiding the actions that our industry needs to take to support our contribution to greenhouse gas emissions reduction and carbon sequestration. So when you think about from the soil perspective, and I think Dr. Acharya, you've made it very clear, we've got to start with the soil. And so Dr. Lal, building on that thinking from Dr. Acharya, what do you think about in terms of the priorities for research in the short, medium, and long term? What do we really need to focus resources on for research to help guide action? And how long will it take to get the answers we need for such an urgent situation? Dr. Lal?
Thank you. Well, I guess you can hear me. I couldn't see you, but I could hear you. Yes, that's a very important part. And we have in this paper described methodology. This methodology that we have described, it needs to be validated under on-farm condition, under different ecoregions. So the research that I would propose is with the companies, with multi-stakeholders in different ecoregion, where the coffee is grown, South America, Central America, Africa, Asia, pick up some eco-regional sites. And at these eco-regional sites, if we can get a kind of a chronosequence coffee plantation, which has been there in existence on the same soil type, on the same region for 25 years, another one maybe for 10 years, another one for 5 years, another one very recent one, that will cut down the time of measurement. So on this chronosequence, within 1 year at the most, it is possible to get information on actual carbon footprint of different production system. So coming back to the specific proposal for WCR, I would suggest to translate this preliminary scientific methodology to make into a standard methodology that can be applied everywhere. Let's pick up key benchmark location in representative soil and ecoregions, and on a chronosequence approach, monitor the carbon footprint using that equation that Umesh described, and evaluate what is the carbon footprint for different land uses. This study can also provide you recommendation what are the land use and farming system that can reduce the carbon footprint and that can make the coffee plantation a sink for carbon. Now, just coming back from the UN Food System Summit and the COP26 that ended in Glasgow, my concern has been on the ground action plan is missing. And I think WCR certainly has this opportunity to document and demonstrate standardization of this methodology, which right now is theoretical. We have no data to validate and test it. So if we can select a benchmark site in 4 different locations to begin with, and it's based on chronosequence approach, and we describe standard methodology, how to monitor and measure emission from soil, how to monitor soil carbon stock, how to monitor the biomass above ground and below ground stock, how to monitor the inputs in a farming system, standardize a template, a protocol, how to do that. I think in 1 year, definitely we can produce results with cooperation from the local institutions in those regions. So that is what I would suggest. It could also serve as a field laboratory for training of scientists of that region, where they could be working and evaluating. They could be finally a MSc or PhD student working on those sites with a local university to get their degree. This way you can have a training as well as on-the-ground validation of the research theoretical protocol that Umesh just presented.
Thank you so much.
Thank you so much.
And building on this question, there are a number of questions coming in from the Q&A, including a specific one. So 25 years of sequestration is great. What do you recommend we do with the coffee wood after the 30-year life cycle?
I will provide some answer. I have been working with colleagues from Brazil, and in fact, this week we produced a spreadsheet, fact sheet on what are the needs for evaluating carbon footprint for coffee. It's a generic, but the idea is after 30 years, if the coffee is not productive anymore, how to translate that into a new coffee plantation, preferably by improved methods, by improved shade trees, by improved management system, so that the emissions from the coffee plantation are minimized and the sequestration from the plantation and the shade trees is maximized. Umesh is right. There are many places this information not available, but there are a few examples. In fact, I had some data to show you, but I decided not to, so that we don't deviate from the main question. There are data from Chinchina in Colombia. There are data from Brazil, where the coffee carbon footprint was computed using soil carbon stock as well. Not all components, erosion, for example, was not there, but they did monitor soil carbon stock to 1 meter depth, which I was very pleased to see. The question really is how to standardize methodology so that everybody in this field follow the same procedure, so that we are comparing apple and apple and not apples and pineapples. If this methodology is not standard, that is why the large variation he showed, 0.4 kilogram to 10.8 or 11 kilogram. We want to minimize that by standardizing methodology. So this is the way to go. I think WC Hara has a great opportunity, many coffee organization institutions. So selecting few key benchmark site, 1 year, well-defined research, we can really provide you some answers. Can't hear you.
How about now?
Good.
Okay. So one of the questions is from Dr. Aaron Davis, that just looking at the in the standing carbon in the coffee trees calculated according to life cycle age or stumping cycle and the fate of the woody biomass post-production. So he's saying, is the standing carbon calculated in that? Could you?
Yes, I will answer that. I had some data actually, which I wanted to share with you, but I did not, where people did calculate the standing biomass both above ground and below ground, both for coffee as well as the shade trees. And that's not available for every site, but certainly there are examples where people have done it. So what we call the terrestrial carbon stock, that's a carbon stock under plantation, both in above ground and below ground biomass of the coffee and the shade trees, plus the carbon stock in the soil. And that information need to be obtained. And there are some examples where it has been done, yes.
So going back to this question of ultimately, there's the calculation for this effort, and then there's the benefit to farmers. And when we think about how farmers benefit from this kind of model, your point about standardization is clear. Obviously, standardized replicable methods are critical for developing market system approaches around this. But what other technical challenges do you find that need to be addressed? So maybe research on the specific questions that would underpin ultimately a standardized method. Where do you feel that is? What is the state either in coffee or in any crop?
Right. Very good. So there are two components. One is how do you standardize the biomass above ground and below ground of plantation, coffee itself, and of the shade trees. So this is a botany. I think that you probably won't know plant science more than I do or Umesh does. So that is one part. How deep do you monitor? Can you standardize rooting depth to 1 meter? Or do you want to go deeper? So how do you evaluate root biomass? Probably develop correlation with the shoot biomass. So that's one part, the root and shoot biomass evaluation of the plantation and the shade tree. The second part is the soil carbon stock, and first to one depth. I would say at least to the rooting depth. So if the rooting depth is assumed to be 0.5 meter, monitor soil carbon stock to 0.5 meter. If the rooting depth for a given site is 1 meter, go to soil carbon stock for 1 meter. So the challenge comes in, how do you assess the carbon concentration in different layers, and how do you assess the bulk density of the soil in different layers? That's a challenge, because you have to convert carbon concentration into carbon stock in soil by multiplying with bulk density. If the bulk density is not monitored carefully, and there's an error margin in bulk density by 10%, you're going to have a 10% error margin in the stock. So that is a major challenge, monitoring soil bulk density properly. And then the other, how do you monitor carbon concentration? In developing countries, people do what they call Barclay-Black method. It's a chemical oxidation method. In our lab here, we have a dry combustion method. Again, if the methodology is not standardized, you're going to get different results. So the manual, eventually, you have come forward in the review article. Probably there should be a manual on methodology for assessment. And that should come back after the on-site validation of the equation procedure that Umesh presented today. If we can do that, then that should end in a manual on how to evaluate carbon footprint. So each methodology is also given in that manual. And hopefully a training program conducted on a regional basis through WCR, where in a 1 week or a few days period, somebody talk about how actually it is done in a real world situation. So the same site we are talking about, we could have a training for 1 week for the researcher, extension agent, producer, how to evaluate the carbon footprint.
And I think that builds on the next question, which is that if you were to take the new accounting system that you're proposing, what's the information that would be needed to make it an easy to use tool? So what are the challenges that you see in using this method, and what do we have to figure out to operationalize it, make it a little more feasible on a steep slope in a place that's hard to get to carry lots of equipment into the field? So what are the operational feasibility sides of this that you would recommend?
Yeah, Umesh, do you want to answer something before I answer?
Yeah, I think I can give it a little bit of a light in here, then Dr. Lal can certainly add up. Whatever we are thinking when we talk about, as a research scientist or as a researcher, you want easy things, Whenever we are calculating the carbon accounting of a coffee, I have seen the paper, just the research is, okay, how much fertilizer you have used, just convert it into the carbon. And pesticides, just whatever the information are easily available, we are trying to use on that one. That way, I'm not telling that it is very hard way to get the information from the field. But if you really go to the farmer's field and talk about them, okay, please, can you give me those information, or can you collect the samples from the soil? They will be more than ready to help there. And for getting I think some of the key, I think the local researcher or local extension agent or the local community mobilizer, they will, if they got a training of a week or 5 days also, they will be able to get specific soil samples, with the auger or some kind of system in there. And other, for calculating the the carbon sequesters in the plant, then if you get one baseline year, and the next year it will be easy. The only from what I think is we have to get kick started on those things, and things will get easy. But like whenever we are doing these kind of research where the producer are in the different area and the concept we are bringing in the different area, that's why we have to involve the universities which knows the local things, and the cooperative or the farmers, coffee farmers. If you talk out with them, I think then the things will get easy to pass on. That should be the strategy. Dr. Lal.
Okay. One, you are CEO of the WCR, so as a CEO, I propose 4-step action plan for next year to consider. And that does not mean you have to come back to our center or somewhere. This is a plan which could be done by implementing. Number 1, select 4 benchmark sites, minimum 4 key ecoregions, 1 Central America, 1 South America, 1 West Africa, 1 maybe 1 East Africa, 1 South Asia, 1 Southeast, whatever number you can implement, 4 sites, 6 sites on a regional basis, which are benchmarked. They represent on a global scale the representative site of the major coffee growing region of the world. And under those sites, over a 1-year period, on the basis of chronosequence, actually evaluate all those parameters that were presented in that model. So we have actual data. If some location have those data, we don't need to monitor. If they do not, we monitor. That's number 1. Number 2 is training. The same site could serve as a field laboratory for training of researchers from the region. 1-week training, 2-week training, something of that nature, not very lengthy. I think 1 week might be adequate. And the training is on the hand-on training on how to monitor bulk density, how to assess biomass, how to evaluate gaseous emission from soil, how to monitor soil erosion from soil, everything included in that. And then number 3rd thing is a manual on how to evaluate carbon footprint. That should come out, which people can use that as a reference guide. And finally, it is asked many times, do we have to monitor carbon footprint on every acre of coffee? The answer is no. We do not have to. If we monitor, develop a methodology protocol properly, then upscaling to similar ecoregion, similar soil type, similar management system can be done through modeling exercise. So 4 components I would like to suggest, and I think most of them could be answered. The first benchmark in 1 year, training may be implemented along with the manual preparation modeling the subsequent year. But in 1 year, at the most 2 years, you could implement all those 4 components globally.
Thank you so much. I think we're very interested to hear these recommendations. I think defining what the key research questions and the process for getting us to move forward is really critical. So we really look forward to continuing to engage with you to develop that action agenda. So it's not all talk, but it's action. So going to this higher level, there's actually quite a number of technical questions in the chat, and we'll seek to develop responses to some of those technical questions. But when we think about, going to the action agenda, what advice do you have for the coffee community on steps we can take today to do a better job of both measuring our emissions and carbon sequestration, as well as actions to actually reduce those and to reduce emissions and enhance carbon sequestration? Is there anything you can point us to, especially with your recent work in Brazil, that would be very helpful for us in terms of actionable next steps while we continue to refine methodologies, come to a set of standardized approaches for the industry? Are there actions that we could take today?
Yes, certainly. And maybe I'll answer that, and then maybe Umesh can add something. One, the immediate strategy, especially in view of the World Food System Summit that we just ended last month, and the COP26 that we ended just this week, how to make coffee plantation negative emission plantation, negative emission plantation. That is really the strategy. That's the goal. With the perennial crop, 25 years and 30 years, with the shade trees, with a lot of biomass of above ground and below ground, and soil always covered, not being disturbed. If it is managed properly, it has to be carbon sink. So the strategy, if I were to be a science advisor to the CEO of WCR, I would say that would be goal number one. How to make coffee plantation a negative carbon emission operation. Negative, not zero. Zero is not good enough. Zero is not acceptable. With perennial crop, even with the annual crop, zero is not acceptable. But with perennial crop like plantation like coffee and with the shade trees combination, then the question is how to identify site-specific practices to make that. Now, in this, I will be amiss if I said variety has no importance. Variety are very important. They have to be. But a good variety can do miracle only if it's grown in a good soil. So we must come up with a recommendation how to keep the ground always covered. That's the key part. So in between, in the initial stages of coffee plantation development, in between the rows of coffee, there must be some coverage of biomass production, especially leguminous one, that will cover the ground, at the same time produce nitrogen. Then we want to find out what are the nutrient requirements, so that we, unfortunately, some of the reports I've read from developing countries, including India, coffee plantation have a negative nutrient budget. And this negative nutrient budget, because of unbalanced fertilization, for example, nitrogen fertilization is cheaper, therefore preferred, and PK and calcium, magnesium, and micronutrients are ignored. So we want to minimize that. So rather than giving a long answer, we want to make sure that there is no negative nutrient budget. And that will automatically create a positive carbon budget. So we can come up with the exact recommendation on how to make coffee a carbon sink. That should be our slogan. That's the goal. That's the point that all the coffee plantations should be thinking about. That is what I was mentioning to Mr. Illy, how to make coffee emission negative.
Wonderful. And I think that goes straight to this question that roasters increasingly want to buy low carbon coffee and are looking for tools to assess this. The proposed carbon accounting system includes parameters that are complex to measure. How could such parameters be practically monitored at a large number of farms? So this is thinking really within a supply chain where a coffee roaster is trying to really do the right thing and incentivize production in these ways. From your experience in other commodities, what are some tools or methods that have been used to allow for this monitoring at such a scale?
Umesh, do you want to begin and then I'll come back?
Yes. Yeah. In this matter, again, I just want to, once you, as Dr. Lal mentioned, if we have a specific methodology and if we have some of the benchmark study on the different eco zones, from there, then there will be, after we have the standards which has been, or the methodologies which has been already proposed, and we can see on what rate, if the farmers are following those, then the deviation we can measure based on the inputs whatever we have done. Because if we are following the shade trees, then this much of a carbon sequestration is there. I think once we did a kind of a research or set a benchmark for our eco zone, after that the other are the difference in the input. Like we mentioned that if we are talking about the use of the chemical fertilizer, if we can exchange that one with some of the organic amendments, like using the farm aid manure or other kind of the organic inputs in there, then we can just change it. I think the setting the standard and developing a protocol, including these aspect in a coffee farming system, I think that will give us a more, and then you can just change some of the aspects on what farmers are doing or not. And by that one, I think the companies or the roasting companies, they can just slightly change those things. I think once you set up a benchmark under the different circumstances on 4 different ecozones, after that it will be more than easy for them to see, okay, if you are following this protocol, then you are not getting that one. And after that, we can, in 5 years, 10 years, we can just go and take the measurements, as a later on, if things are following or not. In one day or in 1 year, you can propose a standard and follow that one, but regular checkup is needed, because later on the rainfall might change or the climate might change. Things are changing every day. I think if in 1 or 2 years, if you set up a benchmark, then it will be easy from my experience on the studies, because there are a lot of the research has been going on the annual crops, and they are changing the rate of the nitrogen or the different kind of the fertilizer, and see what is the emission from the field, or the different varieties, if it is the short or tall varieties, and changing of the biomass. And that same thing we can do that one, at a global level, under WCR. I think that will give us a, because we have WCR who is working with the coffee farmers around the world and with the companies. I think that provides us a more opportunity rather than constraint on developing those kind of methodologies and just change it. Dr. Lal.
Okay. One, in a coffee plantation, the total terrestrial carbon stock in the soil and the biomass is about 100 ton per hectare of carbon, both biomass and soil, maybe 150 ton per hectare with shade trees, maybe under good condition 200 ton per hectare. So we are not here looking for small differences like 100 kilogram or 200 kilogram. We are looking for technology with large differences. And we are looking for technology that you can use economically and remote sensely. So remote sensing observation on benchmark site, where you know what the plantation age is, what the species is, whether it's Arabica or the other coffee, what the shade trees is, whether it's eucalyptus or some leguminous plants. On the basis of that, remote sensing technology can help us on those 4 systems, which I mentioned: benchmark site, training, manual, model. Number 4 part, remote sensing, would be an option to scale up, and make recommendation on the ground how to adopt. Anything which is very laborious and time consuming is not what we should recommend. We are looking here for large differences: 100 tons versus 150 ton versus 200 ton. What are those game-changing systems and model which can really bring transformation of the current system into a carbon sink system? And therefore, I would very strongly suggest remote sensing. We are at the present working with, I don't need to mention the companies, developing a handheld device to monitor soil health indicators. And so a farmer could have those devices, which probably cost maybe something like Wi-Fi, in their pocket when they are going, and they could assess indicators of the soil health. So those are the kind of things we should be thinking about. And occasionally, of course, once in 5 years or so during the plantation time, we need to have ground truthing modeling, evaluation of soil carbon and printed carbon stock, but that's not the routine. Routine is remote sensing and surrogate method. And that's what the manual will tell. We will outline in the manual how to do that. So I think the potential is great, translating science into action. And in this regard, I think private sector can play a very positive and a very constructive role. They can help translate science into action by working with scientists on the one side and the managers at the ground level on the other. So you have really a very bright future in terms of translating science into action.
Thank you so much. And I see that we're at the top of the hour, and I'd like to just take this opportunity to thank both of you for joining us and for your hard work to bring this product to us. It's a really important first step for our organization to really understand this and share this learning with our community, but also to hear from you about what the really pressing priorities and challenges are that we need to mobilize investment and mobilize commitment to move this agenda forward. We realize there's a tremendous amount of guidance and scientific knowledge that we just need to start to translate into actionable steps to move us forward. And you've posed a very hopeful and exciting idea in our heads, this idea of not just neutral, but actually a carbon sink, that seeing coffee production as one of the solution set, a contributor to the solution set as we all think about ways to address this climate crisis. So with that, I'd like to just thank you both for taking time with us today and for your work on this paper. We really appreciate your contributions, and we look forward to continued engagement in the months and years ahead.
Thank you.
Thank you.
Bye.
Bye-bye.